Hi everyone, Mrs. V here, and today we are going to be looking at how to calculate empirical formula and molecular formula using percentage composition data. It's going to be fun. Let's get into it. The first step in determining the structure of any compound is to work out what its chemical formula is. In this video tutorial, we will use percentage composition data to work out the empirical formula of a compound. Using the molar mass, we will then work out the molecular formula. Let's start by explaining what all these terms mean. The molecular formula shows the actual number of atoms of each element in a compound. We see here the structure of propan-1-ol. All we need to do is count the atoms. Carbon, 3, hydrogen, 8, and 1 oxygen. The molecular formula is C3H8O. Try this one. Acetic acid. That's the acid in vinegar. Pause the video and work out the molecular formula. We'll be back with the answer soon. How did you go with this one? Let's go through it. Count the carbons. 2. Hydrogen. 4. Oxygen. 2. The molecular formula is C2H4O2. The empirical formula is the simplest ratio of the number of atoms of each type in a compound. Sometimes it's the same as the molecular formula, as in carbon dioxide. Sometimes you can simplify the numbers. In dinitrogen tetroxide, there's a common factor of 2, so you can simplify that to NO2. This is the empirical formula. Sometimes the empirical formula is the formula of a real compound. Nitrogen dioxide, NO2, does actually exist. But sometimes the empirical formula isn't an actual compound, it's just a mathematical construct. Percentage composition data is just the percentage of each element in a compound as a percentage of the mass of the compound. If we know the percentage composition for a compound, then we can follow some simple steps to determine the empirical formula. This is going to make more sense when we do some examples, but let's just talk through the method anyhow. So the first thing we're going to do, because everything's a percentage, we're going to assume that we've got a 100 gram sample. And that way all percentages are converted straight to grams. We're going to express this as a ratio of all the elements present, because that's really what a chemical formula is. Then we're going to convert all of those masses to moles, and then we're going to simplify the ratio of the moles by dividing throughout by the smallest number. Sometimes we get halves and we'll need to multiply through to get whole numbers. Usually we just need the first 4 steps. Let's try an example. A compound is found to contain 50.05% sulfur and 49.95% oxygen by mass. What is the empirical formula for this compound? Let's just follow our method. Step 1, we're going to assume we have a 100 gram sample. So that will mean we have 50.05 grams of sulfur and 49.95 grams of oxygen. And we're going to express that as a ratio. Now we're going to convert those masses to moles by dividing by the relative atomic mass. We're going to run those through the calculator. Now this is the step people forget all the time. They forget to simplify the ratio. To simplify a ratio, you just divide throughout by the smallest number. In this case, we're going to divide throughout by 1.561. If we run that through the calculator, we get a ratio of 1:2. That means there are 2 oxygen atoms for every sulfur atom. We don't need to multiply by anything to get whole numbers. We already have whole numbers, so we don't need step 5 this time. The empirical formula is SO2. It's your turn now. Pause the video and work through this one. We'll be back with the answer soon. How did you go? Let's check you're working. Carbon to hydrogen to oxygen in this one. The ratio of the masses in a 100 gram sample just goes with the percentages. Now we're going to convert them to moles. Running that through the calculator. Now divide through by the smallest number, 1.349. That's going to simplify to 4:10:1. Again, we won't need that step 5. The empirical formula is C4H10O. Once you know the empirical formula, there's just one more step to calculate the molecular formula. You're going to need the molar mass. This might be given to you in the question, or if you have the mass spectrum, you can just get it from the molecular ion peak. Remember, the molecular formula is a whole number multiple of the empirical formula. All you need to do is find out what that number is. That number is called the multiplier. You calculate it by dividing the molar mass of the compound by the molar mass of the empirical formula. Let's have a go. Analysis of a compound containing only carbon and bromine revealed that it contains 6.99% carbon by mass and has a molar mass of 343.62 grams per mole. What is the molecular formula of the compound? First of all, if the compound's 6.99% carbon, then it's 93.01% bromine, because it only contains carbon and bromine and the percentages have to add up to 100. First of all, let's calculate the empirical formula. Convert the masses to moles. Run that through the calculator. Simplify. Dividing through by 0.582 gives you 1:2. The empirical formula is CBr2. Now we can calculate the multiplier, molar mass divided by the molar mass of the empirical formula. That equals 2. Now we just need to multiply the empirical formula by the multiplier to get the molecular formula. The molecular formula is C2Br4. You know I wouldn't leave without giving you a turn. Try this one. Caffeine contains 49.5% carbon, 28.9% nitrogen, 16.5% oxygen, and 5.1% hydrogen by mass. Its molar mass is 194.2 grams per mole. Find its molecular formula. Pause the video, have a go, and come back to check you're working. Empirical formula, masses. Convert to moles. Run it through the calculator. Simplify. We get 4:2:1:5. So the empirical formula is C4N2OH5. Calculate the multiplier. Molar mass divided by the molar mass of the empirical formula. Run that through the calculator and you get 2. The molecular formula is 2 times the empirical formula. So the molecular formula is C8N4O2H10. How did you go? Did you get it all right? Well, I hope you found that video useful, and if you did, please give it a like. And as always, please subscribe to my channel, watch more videos, keep learning more about this wonderful subject of chemistry. I'm going to see you guys in the next video.